chapter 3, that is electrochemistry. You know, in most of the exams, CBSE board exam, NCERT exercise questions are very important from the examination point of view. So first question is, arrange the following metals in the order in which they displace each other from the solution of their salt. So you know what is the relation? More active metals can displace less active metals. More active metals can displace less active metals, right? More active metal can displace less active metal. So those which are more active can displace the less active metals. So which one is most active metal? We have to arrange the following metals in the order in which they displace each other from the solution of their salt. Just write the order. Which one is most active metal? One is the most active metal. You know, magnesium. It is most active metal that can displace all of them from the solution. And then it is aluminium. After that comes zinc, then iron, and at the last it is copper. So this is the order: magnesium, aluminium, zinc, iron, and copper. Okay. In this way, they displace each other from the solution of their salt. Magnesium can displace all, aluminium can displace zinc, iron, copper. Zinc can displace iron and copper, iron can displace copper, and copper is not able to displace any one of them. This is the first question. Second question, given the standard electrode potentials are given, means reduction potentials are given. Standard reduction potential are given to you. So by using these standard reduction potentials, or we can say electrode potentials, we have to arrange these metals in their increasing order of reducing power. See, lower the reduction potential, that means higher is the oxidation potential, stronger is the reducing agent. This is the case because reducing agents are one which can oxidize easily. Okay. What is reducing agent? If we define reducing agent is the substance which can reduce others and itself gets oxidized. That means it should have high oxidation potential, or we can say lower reduction potential. So which one has lowest reduction potential? That should be the strongest reducing agent. we should write in the increasing order. So that means the one having highest reduction potential is the weakest reducing agent. So first is silver, right? And then after silver, the silver has 0.80 volt reduction potential. Then comes mercury. Next is, out of this, next is chromium. Lower negative value means higher reduction potential. Okay. So after chromium, it is magnesium, then potassium. Potassium has highest negative reduction potential. That means it has a minimum reduction potential. So it is the strongest reducing agent. The order of reducing nature. Then answer if you are able to answer it. Okay. Next question. Depict the galvanic cell in which the reaction zinc solid plus 2 Ag plus aqueous to give Zn 2 plus aqueous plus 2 Ag solid takes place. Further show which of the electrode is negatively charged, the carriers of the current in the cell, and last is individual reaction at each electrode. First, we have to depict the galvanic cell in which the reaction takes place. So, is cell representation. So what is cell representation? Cell representation is, first we write anode part, then solid bridge, then cathode part. This is the way to represent. That means first we write zinc solid to zinc 2 plus aqueous. That is anodic part, anodic half cell, oxidation half cell, then double arrow, double vertical line that represent the salt bridge. This double vertical line represent the salt bridge. Then cathode part, Ag plus aqueous to Ag solid. So this is the cell representation of the given galvanic cell. Now, first question is which of the electrode is negatively charged? So tell me, in electrochemical cell we use this term, lone. What do you mean by lone? Left oxidation, anode, negative. That means anode is negatively charged electrode. Anode is negatively charged electrode. So out of silver and zinc, which one is anode? Where oxidation takes place. So that means zinc is negatively charged electrode. Zinc electrode is negatively charged electrode. Okay. Now second part, the carriers of the current in the cell. So carriers of the current in the cell are electrons. Electrons are the carriers of the current, and current is flowing. Electrons are the carriers of the current, and electrons flow from zinc to silver, and current in opposite direction. Current flows from silver to zinc. Move from silver to zinc because electron flow from zinc to silver. So convention current is opposite to the electronic current. That's why current flows from silver to zinc. Now individual reactions at each electrode. Individual reactions at each electrode. So at anode, what is the reaction at anode? See, zinc 2 plus. So at anode reaction taking place is zinc solid to give Zn2 plus aqueous plus 2 electron. Okay. And what about cathode? At cathode, copper 2 plus aqueous plus 2 electron. Sorry, it is not copper, it is silver. So we will have reaction like Ag plus aqueous plus electron to give Ag solid. Yes, beta. Up to this, understood? Yes, Dharampreet Singh, zinc is more reactive. Now tell me, is it okay? Up to this? Yes, beta. Next question. Next question is of galvanic at the delta G naught and equilibrium constant of the reaction. So first of all, I will write the equations. Okay. First one, to calculate standard number of electrons transferred and F and its value is see minus minus cancel, just remove it. NF E naught over 2.303 RT. So this is the value, or we can say E naught cell is equal to yes 2.8 Kelvin. Standard temperature is 298 Kelvin. Okay. It is E naught cell. The R T log of K. Okay. Or we can write log K equal to E naught cell 0.0. First question. So that means V 3 plus 2 chromium, cadmium 2 plus 2 cadmium, Fe 3 plus 2 Fe 2 plus, and Ag plus 2 Ag. We need E naught values of all of them. So that should E naught get E naught cell first. Yes, beta. What is E naught cell? E naught cathode minus E naught anode. 196,860. So it is equal to minus 196.86 kilo answer of the first question. Okay. Yes, beta. Got it? It is minus 190. Next question is question number 2. Question number 2 of 3.4 part. Fe2 plus Ag plus Fe3 plus Ag. Okay. Second question is Fe2 plus Ag plus give Fe3 plus Ag solid. So in this case, again, these values of E naught Fe3 plus to Fe2 plus, it is given to you. E naught Fe3 plus to Fe2 plus, it is 0.77 volt, and E naught of Ag plus to Ag, what is the value? 0.80 volt. So these E naught values are given to you. Okay. So now first is calculate E naught cell standard cell potential. So it is E naught cathode minus E naught anode. So E naught cathode minus E naught anode. So what is cathode? Cathode is silver. So E naught silver minus E naught of iron, Fe3 plus to Fe2 plus. So what is the value of silver? 0.80 minus Fe3 plus to Fe2 plus. It is 0.77. Means it is 0.03 volt. So this is E naught cell of this particular cell reaction. Okay. Now next part is calculate. This is first part. Then A. Now B part. Delta G naught. So delta G naught equal to minus NF E naught cell. Tell me what is the value of N in this case? What is the value of N in this case? Yes, beta. What is the value of N in this case? Value of N. See, Fe2 plus to Fe3 plus. How many electrons are involved? Convert Fe2 plus to Fe3 plus. How many electrons are involved? Only one. So that means one electron. Ag plus to Ag. Again one electron. That means N in this case is equal to 1. N is 1. Okay. In this case, N is equal to 1. Okay. N is equal to 1. Okay. So just put the value. the value of N. N is 1. So minus 1 into 96500 into 0.03. So this is in coulomb volt per mole. Coulomb volt per mole is it is equal to 96500 into 0.03, that is 2895 joule per mole, is 2.895 kilojoule per mole. 2.895 kilojoule per mole, but with negative sign, minus 2.895 kilojoule per mole. Now C part. Okay, C part here we have to calculate C part in each case equilibrium constant of the reaction. Now to calculate equilibrium constant, just use this. Log K equal to N into E naught cell upon 0.059 is log K equal to N into E naught cell divided by 0.059. So what is N in this case? 6. And what is E naught? 0.34 divided by 0.059. So it is equal to 6 into 0.34 divided by 0.059. So it is 34.5763. 34.576 around. 34.5736. Okay. So what is the value of K now? Okay. See, delta G naught equal to 2.303 RT log K. So log K equal to, because minus minus cancel, 2.303 RT upon NF. It is 0.059 over N into E naught upon 0.059. Calculate K. E naught value is 0.34, N is 6, divided by 0.059. Am I right? 6 into 0.34 divided by 0.059. Yes, it is 34.5763. K is anti-log of this value. Calculate the anti-log of this value. First say, am I right or something more is required? Because delta G naught equal to minus 2.303 RT log K. If we use this one, so log K equal to delta G naught upon 2.303 RT. So minus, what is delta G naught? 196860. 196860. 2.303, 8.314 into 298. Keep in mind, standard temperature is in electrochemistry, thermodynamics, it is 298. So what is the value? 196860 divided by 2.303. divided by 8.314 divided by 298 is 34.501, almost same. 34.501 that is log K. So if we use simple, see in this case 0.059, that is approximate. To some extent it is approximation. So it is 34.5763. So anti-log of this value 34 becomes 10 raised per 34 into anti-log of 0.5763. 0.5763 anti-log, it is 3.769, is almost 3.8. It is 3.8 into 10 raised to power 34. And if we use this value, then again K is anti-log of 34.5014, that is 10 raised to power 34 into 0.5014 anti-log, it is 3.2, is almost same. The result is between 3.2 into 10 raised to power 34 to 3.8 into 10 raised to power 34. Any answer in between that is the correct answer. Any answer between these two terms is the correct answer. Okay. Got it, beta? Done? Yes, beta. Is it okay? Shall we go to next question? Yes, so next question is, okay, now in this case, just again log K equal to N into E naught cell divided by 0.059. Here N is 1, and what is E naught cell? E naught cell is 0.03 divided by 0.059. So value comes out to be 0.03 divided by 0.059. So it is 0.5085. 0.5085. K equal to anti-log of 0.5085. So it is 0.5085. Anti-log is 3.225. Is 3.225. This is the value of K in the second case. The first case, it is 3.2 into 10 raised per 34 or 3.8 into 10 raised per 34. Okay, so this is question number 4, first and second part. Now 3.5, very important question. There is always a question from this part. Write the Nernst equation and EMF of the following cells at 298 Kelvin. So first question is Mg2 plus, Mg solid to Mg2 plus 0.001 molar, copper 2 plus 0.0001 molar, copper solid. So this is the cell. Right? Now, first of all, to write the Nernst equation, we should write its Nernst equation. First write the cell reaction. So cell reaction is, just write the cell reaction. Cell reaction is the one on the left side of this vertical line, that should be written on the left side, and those on the right side should be written on the right side. See, in this case Mg solid is on the left side, and here copper 2 plus is on the left side. So 0.001, that means 10 raised to power minus 4 molar to give Mg2 plus, and its value is 0.001, means 10 raised to power minus 3 molar plus copper solid. So this is the way to write the Nernst equation, write the cell reaction, and now balance the charge. Mg plus, Mg solid, copper 2 plus. On the left side there is 2 plus charge, on the right side there is also 2 plus charge. That means charge is balanced, magnesium atoms are balanced, charge is balanced, atoms are also balanced. Charge as well as atoms both are balanced. So now come to next part. According to Nernst equation, E cell is equal to E naught cell minus 0.059 divided by N log of product over reactant. So product is Mg2 plus raised to power 1, copper 2 plus raised to power 1, and copper solid and Mg solid both are not written, because for pure solid and pure liquid we take them as unity. Their concentration is taken as unity. This is the standard. Okay. If you wish to see the why is it so, there is a video, the playlist, you can check in I think states of matter chapter, and why is pure electrochemistry chapter, why pure solids and pure liquids their concentration is taken as unity, because their density is constant. If mass changes, even then density remains same. That's why they are taken as unity. Now next part, in this case E naught values should be given to you. I will write here these values. When this question comes, values of E naught are given to you. E naught Mg2 plus Mg, and E naught copper 2 plus to copper. You know, copper 2 plus to copper value is 0.34 volt. Value is 0.34 volt. Value is 0.34 volt. Okay. And what about value is 0.34 volt, and for magnesium 2 plus to magnesium value is minus 2.37 volt. Right? For magnesium its value is minus 2.37 volt, and for copper it is 0.34 volt. So from these values we calculate E naught cell. And what is N in this case? Obviously Mg to Mg2 plus. How many electrons are involved? 2. Copper 2 plus to copper 2. So N in this case is equal to 2. N is equal to 2. So just put the values. E naught cell is E naught cathode minus E naught anode. What is cathode here? In this case, cathode is copper and anode is magnesium. So E naught copper 2 plus copper minus E naught magnesium 2 plus 2 magnesium. What is the value of copper? Value of copper is 0.34. And what is the value of magnesium? Minus 2.37. That means 0.34 minus plus 2.37. That is 2.71 volt. 2.71 volt. So that is the value of E naught cell. Now N we have concentration of Mg 2 plus copper 2 plus. That is also given to us. This is the concentration of copper 2 plus, concentration of Mg 2 plus. So now just calculate E cell. E cell equal to E naught cell, that is 2.71 minus 0.059 over N. N is 2 log of 10 raised to power Mg2 plus 10 to the power minus 3 divided by 10 raised to the power minus 4. So that is 2.71 minus 0.059 over 2 log of 10. And what is the log of 10? 1. So E cell is equal to 2.71 minus 0.0295. 0.02955. So now 2.71 minus 0.02955 comes out to be 2.68 around. So 2.68 volt is the EMF of the cell. So EMF of the cell is equal to 2.68 volt. Yes, beta. This is the use of Nernst equation. Now, second part. Fe solid to Fe2 plus 0.001 molar, then H plus 1 molar to H2 gas, 1 bar. It is solid. First of all, write this reaction. Okay. F is solid. Fe2 plus 0.001 molar. 0.001 molar means 10 raised to power minus 3 molar. H plus 1 molar H2 gas 1 bar PT. Okay. So cell reaction is the second part. Okay. So cell reaction is Fe solid plus H plus 1 molar to give Fe 2 plus 10 raised to power minus 3 molar plus H2 gas 1 bar. Right? Now balance it. Fe2 plus. On the left side, there is 1 plus charge. On the right side, there is 2 plus charge. And hydrogens are also not balanced. Now, hydrogens are balanced. Charge is balanced. Okay. Now, according to Nernst equation, E cell is equal to E naught cell minus 0.059 over N log of product over reactant. In product, Fe2 plus is given. So Fe2 plus concentration. Hydrogen is given as a gas. So if gas is present, just write its pressure. Pressure of hydrogen divided by Fe solid. No need to write. H plus sign raised to power 2. So this is Nernst equation. Now to calculate E naught cell, first of all, we should know E naught values. So keep in mind E naught values, they are given to you. No doubt in this question it is not given, but when question comes, obviously E naught values are given to you. Okay. So E naught Fe2 plus 2 Fe. What is the value of E naught Fe2 plus 2 Fe? So E naught Fe2 plus 2 Fe, it is minus 0.44 volt. And for hydrogen, you know, value is always 0. Is SHE, standard hydrogen electrode. So E naught cell equal to E naught cathode minus E naught anode. What is value of E naught cathode? It is 0. And for anode, it is minus 0.44. Minus plus, that is 0.44 volt. This is E naught cell. Next is value of N. So keep in mind the value of N in this case is 2. Value of N is 2. Why is it so? Because Fe to Fe2 plus, how many electrons are involved? 2. H plus 2, H2, 2H plus 2H2, again 2. N is 2. And just put the concentration values. Let us calculate E cell now. So E cell equal to E naught cell. Value of E naught cell is given. We have calculated 0.44 minus 0.059 over N is log 2, and then Fe2 plus 10 raised to power minus 3. 10 raised to power minus 3, pressure of hydrogen 1, and H plus ion concentration is also 1. So just solve it like this. Log of 10 raised to power minus 3 only. Minus 3 log 10, and log 10 is 1, is 0.44 minus 0.059 over 2 into minus 3 log 10, and log 10 is 1. So E cell equal to 0.44 minus 0.059 by 2 into 3. Minus plus. Yes, minus 3. So minus plus. So in this way, the value comes out to be 0.059 into 3 divided by 2. So it is 0.0885 plus 0.0885. So it is 0.44 plus 0.0885. So it is 0.5285. 0.5285. So E cell is equal to almost 0.53 volt. 0.5853 volt, or you can write complete fraction. So it is 0.5285 volt. That's it. Yes, beta. Any doubt up to this? So by using the same relation, you can do for third and fourth. E naught value of H plus is there and bromine. So keep in mind the values I will write and you will solve it by your own. Okay. E naught of Sn2 plus 2 Sn and E naught of Br2 negative here. E naught Sn2 plus Sn is minus 0.14 volt and plus 1.08 volt. Okay, so do third and fourth part by your own. Okay, it is homework for you, and just write the answer in the comment section for 3.5 third and fourth. Okay, that's all. Thank you so much to all of you. Okay, bye then.